Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்க. எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yes, good afternoon students. In the first video we discuss what is chemical bond, what is Lewis theory, and how to write the Lewis dot structures we discussed. And next one is ionic bond. Please write down ionic bond. Ionic bond. What is ionic bond? The electrostatic force of attraction between two oppositely charged ions formed by transfer of electrons from one atom to another atom, that is called ionic bond. What is ionic bond? The electrostatic force of attraction between force of attraction between two oppositely charged ions formed by transfer of electrons from one atom to another atom, that is called ionic bond. What is ionic bond? Ionic bond is electrostatic force of attraction between two oppositely charged ions formed by transfer of electrons from one atom to another atom. Ionic bond, another name is electrovalent bond. It is another name is electrovalent bond. What is electrovalency? Any atom, the atom losing electrons, that is called electrovalency. The atom losing electrons, that is called electrovalency. Now here is formed between metal plus non-metal. Where is a ionic bond formed? Metal plus non-metal. Metal is a electropositive element, non-metal is electronegative element. Here it is another name is electrovalent bond, or it is formed between metal and plus non-metal. Another one, metals are electropositive nature. For example, if you take first A group elements and second A group elements, first A group elements hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Next second A group elements are beryllium, magnesium, calcium, strontium, barium. These are called metals plus non-metal. We can take example NaCl. NaCl is the example of ionic bond. Next one is magnesium chloride, MgCl2, and MgO, magnesium oxide. These are the, here is sodium is the metal and chlorine is the non-metal. Here also magnesium is the metal, chlorine is non-metal. Now here is magnesium and oxygen. Here magnesium is the metal and oxygen is the non-metal. Now we can do it NaCl. For example, we can take NaCl. Now electrostatic force of attraction between two oppositely charged ions formed by transfer of electrons from one atom to another atom. It is another name is electrovalent bond, where it is formed metal plus non-metal. Metals are electropositive nature, non-metal is electronegative. If you take example, we can write it. The example is NaCl. NaCl is the example. Now the atoms are why involved in bonding? Because their stability purpose. Now I am writing first one is sodium. What is the electronic configuration? The atomic number is 11. And now write 1s2, 2s2, 2p6, 3s1. This is the electronic configuration. Here is Na losing. Here is 2, 6 plus 2, 8. 2, 8, 1. It is removing electron. Removing electron means Na plus. If losing electron means plus, here is electron is formed. Here is sodium, electronic configuration is 1s2, 2s2, 2p6, 3s1. Here one electron is losing sodium to attain nearest noble gas configuration. Which is the nearest noble gas configuration? It will be neon configuration. They want to stable. Here also this one is the gas, here is a solid. After, if you take a chlorine, Cl, what is the electronic configuration of chlorine? We can take which group? This one, 1s2, 7th group, 1s2, 2s2, 2p6, 3s2, 3p5. Here is how many electrons? 17. Atomic number is 17. Here is 10, 5, 2. This is the 7th group elements: fluorine, chlorine, bromine, iodine, astatine. Now here is chlorine is accepting electron. One electron is accepting to form Cl minus. Here is Cl minus is formed. Here Cl minus means it is having nearest noble gas configuration is argon. Argon is the nearest noble gas configuration. Here first one is sodium, gas is formed. Here is also gas. Here is gas is formed. Now Na plus and Cl minus. What is the definition? The electrostatic force of attraction between two oppositely charged ions are formed by transfer of electrons between one atom to another atom. Which one is losing electron? Here is sodium is losing electron. If losing electron means Na plus is formed. Chlorine is accepting electron to gain the nearest noble gas configuration. Here is sodium is losing electron to getting nearest noble gas configuration, neon. Here is argon. Now the electrostatic force of attraction between two oppositely charged ions are formed by transfer of electrons from one atom to another atom. That is called ionic bond is formed. Ionic bond. If you write Na plus and Cl minus, how many? 1, 2, 3, 4, 5, 6. We can take minus charge. Total 8 electrons. No? 8 electrons after only. Here is transfer already 1 electron. Here is minus. This one is the Lewis dot structure of this one. Lewis dot structure. Here is Na plus is losing electron. Already 7 electrons are present. 1, 2, 3, 4, 5, 6, 7. One extra electron is sodium is giving to form bond. If you write the Lewis dot structure, Na 1 electron. Here is 1 electron. Chlorine 1, 2, 3, 4, 5, 6. Here 7. This electron is like this. This is the Lewis dot structure of NaCl. Don't confuse here. Na plus is losing one electron. Chlorine is accepting electron. Here is accepting already. 7 electrons are present. 7 valency electrons of 17th group element. 7. 1, 2, 3, 4, 5, 6, 7. One extra electron is given. Sodium. This is called ionic bond. What is ionic bond? The electrostatic force of attraction between two oppositely charged ions are formed by transfer of electrons from one atom to another atom. That is called ionic bond. If you take magnesium chloride, if you take MgCl2, magnesium chloride, this one also example. I am taking magnesium. What is the electronic configuration? 2, 8, 2. Here is losing 2 electrons. Magnesium plus 2 electrons. Here is magnesium 2, 8, 2. Here is losing 2 electrons. How many chlorines are present here? 2 chlorines are present. Each chlorine, first chlorine, here has accept 1 electron to form Cl minus. Another chlorine accept electron, Cl plus electron gives rise to Cl minus. Now here is there 1s2, this one also 2, 8, 8, here is how many? Here is chlorine 2, 8, 7, not 8, 2, 8, 7. Here is 1 electron is accepted. 2, 8, 8 is formed. Nearest noble gas. Here also 2, 8, 7. Here is accepting 1 electron. 2, 8, 8 is formed. Now magnesium plus 2 plus 2 Cl minus, because 1 chlorine 2 Cl minus to form magnesium chloride is formed, MgCl2. Now Lewis dot structure we can write it. Magnesium how many electrons? 1s2, 2s2, 2p6, 3s2. This is the outermost electron. Now here is 2 chlorines, 1, 2, 3, 4, 5, 6, 7. Here is 1 electron is accepted. Here also chlorine I am taking 1, 2, 3, 4, 5, 6, 7. This is the Lewis dot structure of MgCl2 and sodium chloride. These are the 2 examples of ionic bond. Now what is the electrovalency? Here is Na plus is the gas and chlorine also gas. The 2 gaseous are combined to form NaCl, solid is formed. Now I am taking NaCl and magnesium chloride is the 2 are the examples. We can take magnesium oxide also, example of ionic bond. Okay. Now we will discuss electrovalency of first A and second A. What is the electrovalency? Per atom it is losing electrons is called as electrovalency, sharing electrons is called, that is covalency. Now write first A group elements. What is the showing electrovalency? I am taking first A group elements and electrovalency, that is it showing first A group elements 1. Okay now, electrovalency of first A group elements, for example sodium, lithium, sodium, magnesium, lithium, sodium, potassium, rubidium, cesium, francium. Next one is second A group elements, beryllium, magnesium, calcium, strontium, barium. It is showing electrovalency is 2. If third A group elements is 3. Boron, aluminium, gallium, indium, thallium. Next one is fourth A group elements. Here is fourth A group elements, carbon, silicon, germanium. It is not showing any electrovalency. They are form only covalent bonds, they not form ionic bonds. And if you take fifth group elements. Fifth group means nitrogen. It's also showing 3 electrovalency. If you take sixth group elements, that is electrovalency is 2, oxygen, sulfur, selenium, tellurium, polonium. If you take seventh group elements, they are showing that is 1, electrovalency is 1. Now first year group elements, what are the first year group elements? Hydrogen, lithium, sodium, potassium, rubidium, cesium. These are electrovalencies 1. Now second year group elements, beryllium, magnesium, calcium, strontium, barium, radium. They are showing 2 electrovalency. If you take third year group elements, 3, fourth year group elements are not showing electrovalency, and fifth year group elements means 15th group elements, nitrogen, phosphorus, arsenic, antimony, bismuth. Now that is 3. Sixth means 2, oxygen, sulfur, selenium, tellurium, polonium is 2, and seventh group elements, that is 1. Now what are the favorable condition for ionic bond formation? Now I am taking metal, here I am taking metal, here metal is converted to metal ion M plus electron. Here is metal in a gaseous state, it is isolated atom. What are the favorable condition? Here is, this is the gaseous state and neutral atom, and here is giving 1 electron. What is the energy, that one? Ionization energy. What is ionization energy? The amount of energy required to remove the valency electron of isolated neutral gaseous atom, that is called ionization energy. Here is ionization energy means the amount of energy required to remove the valency electron of isolated neutral gaseous atom. Here is negative energy, always here is positive, delta H is equal to positive, because energy is absorbing, that is called ionization energy. Now I am taking X plus, this one also gas. Now here is electron is accepted to form X minus. Now electron is accepted means X minus, it is losing means M plus. Now here is electron affinity. Electron affinity. What is electron affinity? The amount of energy released. The amount of energy released to add extra electron in outermost orbital or outermost orbital of or outermost shell of gaseous neutral isolated atom, that is called electron affinity. Here is electron affinity, delta H is equal to here is negative, here is negative, here is a positive, delta H is equal to positive. Why? The amount of energy required to remove the electron. Now here M plus is formed in a gaseous state and X minus also gaseous to form MX, solid form is formed, solid. Now both the gases, for example Na plus is formed, Na plus is the gaseous and Cl minus is also gaseous. Both gases are unstable, they are reacting, they are combining to form NaCl solid. Now NaCl solid is the stable. These are the favorable conditions for ionic bond formation. Now first one is ionization energy. Ionization energy means the amount of energy required to remove the electron, removing outermost electron. Now here is electron affinity means extra electron is adding to the outermost shell of isolated gaseous neutral atom. These are the ionic bond formation important points. You can easily copy it, write it. M plus X minus, there is M plus is formed, X minus, Mx is solid. Now I am explain properties of ionic bond. What are the properties of ionic bond? We can write one by one. Properties of ionic bond. What are the properties are there? The properties of ionic bonds, heading properties of ionic bond. Properties of ionic compounds, we can write it ionic compounds or ionic compounds. Properties of ionic compounds. When ionic bond is present, that is ionic compound. No? Now property. First property is a physical state. Write down physical state. Physical state. Here is ionic compounds are because the electrostatic force in a solid, maximum this physical state is solid because the strong electrostatic force of attraction between two oppositely charged ions in a solid, the physical state is hard crystalline, hard crystalline and brittle nature. Hard crystalline and brittle nature. The physical state is, what is the, actually it is solid form. Solids are definite shape, definite volume, that is a hard crystalline and brittle nature. If you take isomorphism, ionic compounds are not showing isomerism, ionic compounds are showing isomorphism. Isomorphism means similar electronic structure, similar electronic configuration. Next one is 3D structure. The crystal structure also similar. 3D crystal structure. Crystal structure is same. Crystal structure 3D structure is same. If you take sodium NaF, next one is magnesium oxide. Here is isomorphism. Ionic compounds are not showing isomerism. What is isomerism? Isomerism means same molecular formula, different physical, chemical, biological properties. What is isomerism? Same molecular formula, different physical, chemical, biological properties. That is called isomerism. Again, isomerism is divided into two types: structural isomerism, stereoisomerism. Structural isomerism means same molecular formula and different structural arrangement. Structural arrangement means chain isomerism, positional isomerism. Next, functional group isomerism, tautomerism, metamerism, ring chain isomerism. These are the different types we can discuss in organic chemistry, but here is isomerism. Ionic compounds are not showing isomerism, they are showing isomorphism. What is isomorphism? Similar electronic configuration, crystal structure also same. Here is sodium, I am taking Na plus F minus. Here is magnesium plus 2 O2 minus. Now write what is the electronic configuration, 2, 8. Here also 2, 8. Fluorine. Here is magnesium also 2, 8. Oxygen is 2, 8. Why? Because here is sodium is 1s2, 2s2, 2p6, 3s1. One electron is losing. The fluorine is accept that electron 2, 8. Now here also magnesium plus 2, O2 minus. This similar electronic configuration, crystal structure is same. They are showing isomorphism. Next to physical state, they are hard, crystalline, brittle nature. What are the crystalline substances? The crystalline substances having similar, that is definite shape, definite volume, incompressibility. They are orderly arranged. The solid is orderly arranged. Liquid, there is somewhat difference. And gaseous, the molecules, ions are far away from each other. And which one is a more entropy? Entropy is more gaseous because more disorderness is present. More disorderness means that is more entropy. We can discuss in thermodynamics. This one is now isomorphism. Next one is another one is conductivity. Conductivity, conductance. What is the properties of conductivity? Actually, ionic compound in solid state, for example, solid NaCl, it acts as a bad conductor. Why bad conductor? Because there is a strong electrostatic force of attraction is present. There is strong electrostatic force of attraction is present in solid state. The NaCl is a bad conductor. If you take aqueous state, and fused state, if you dissolved in water, aqueous, it is act as a NaCl act as a good conductor. Why good conductor? Because they releasing ions, cation, anion, the good conductor. In aqueous state, ionic compounds are in solid state bad conductor. In aqueous state and fused state, it is a good conductor because conductance, because number of ions increases, conductance increases. Now another one is the melting and boiling point. Melting, MP and BP. What are the points? Ionic compounds are high melting point and boiling point. It is having strong electrostatic force of attraction is present due to ionic compounds are high melting and boiling points. Next one is ionic reactions are very fast reactions. Ionic reaction, for example, NaCl, I am taking AgNO3 gives rise to, we can take AgCl plus NaNO3. This is the ionic reaction. For ionic reaction, we cannot determine the rate. We cannot determine because it is completed 10 to the power minus 6 seconds. It is very, very fast reaction. We cannot determine the rate of reactions for ionic compounds. These are the physical properties. Another one is the solubility. First one is the physical state. Ionic compounds are hard, crystalline, brittle nature. Isomorphism, they are not showing isomerism. Similar electronic configuration, crystal structure is same. Next one is the conductivity. Another property is melting and boiling point. Another one is the solubility. What is solubility? Solubility means solubility, more dissolving in water. Solubility, for example, NaCl is the ionic compound more soluble in polar solvents. What are the polar solvents? What is polarity? Poles, whether molecule is polar or non-polar will decide by dipole moment. Now NaCl is more soluble in polar solvents. Now ionic compounds having more solubility. Now Na plus soluble in water. Na plus is association with negatively charged oxygen. In a hydrogen molecule, oxygen is there, na? That oxygen negatively charged. This is the association. Next to this one is hydrogen. Here also hydrogen, it is negative. Here is positive. Here is hydrogen. Here also hydrogen. Here is negative. Now sodium ion is interaction with negatively charged oxygen atom of water molecule. Here is chlorine. Chlorine is association with positively charged hydrogens. That's why ionic compounds having more solubility in polar solvent. If you take covalent compounds are more soluble in non-polar solvents. Whether polarity and non-polarity is decided by, that is dipole moment. Dipole moment is the vector quantity. We can discuss that one later. These are the properties of the ionic compound. If you take a covalent bond, what is the covalent bond? We can discuss after this. Covalent bond. Ionic bond is a non-directional. It is no direction is present, but covalent bond is directional. Write down. What is a covalent bond? Already covalent bond explain. Covalent bond. Write down covalent bond. covalent bond. Here I am taking Cl, here is one atom, I am taking chlorine, here also another chlorine. Here is seventh group elements means 1, 2, 3, 4, 5, 6. Here is one electron from this chlorine, one electron. Here also 1, 2, 3, 4, 5, 6. Now what is covalent bond? And the shared pair of electrons are mutually sharing. The pair of electrons are shared by mutually. Here one atom, chlorine atom is giving one electron, another chlorine atom is giving another electron. This pair of electrons are shared by two atoms mutually. This is called ionic bond. Next we can take hydrogen. Here is one hydrogen atom is giving one electron, another hydrogen atom is giving another electron. This pair of electrons are shared by two atoms. That is a covalent bond. If you take nitrogen, nitrogen belongs to which group? It belongs to fifth group, means 1, 2, 3. Here also 1, 2, 3. Here nitrogen I am taking how many valency electron? Nitrogen 5. Now this shared pair of electrons mutually sharing between two atoms, that is called covalent bond. If you take oxygen how many? 1, 2, 3, 4, 5, 6. Another oxygen atom also 1, 2, 3, 4. We can take like this 1, 2. This is the covalent bond. This pair of electrons, two atoms are mutually sharing, because this atom is giving one electron, this atom is giving another electron. This pair of electrons are mutually sharing. These are the example of covalent bond. Now polar covalent bond. Polar covalent bond means here I am taking hydrogen, here is one, another one is the chlorine I am taking, here is chlorine, 1, 2, 3, 4, 5, 6. Here is mutually sharing between two atoms. This is called covalent bond. Covalent bond is the directional bond. Covalent bond is the directional bond. These are the covalent bonds. Important. We can write like this. Okay. Today next class, please listen. That is Lewis dot structures and lattice energy hybridization. One by one we can discuss. Thank you. You are viewing my classes. Please subscribe and comment it and like it. Thank you.